Okay, let's start our week 4 today, where we are going to now see the next layer, but from the bottom one. So there is one which we are actually discussing today is the data link layer. Okay, so data link layer is the today's one which we are going to have a look. So first of all, just to have a quick recap, please uh, stop talking, everyone. So we know that like how actual communication move from top to bottom. It start from application, go to physical, and on the other side it is going to physical and then toward the upper one. So actual communication proceed down through each layer and then passing down to the next, and then it's keep going on throughout the each network up till the main one. So let's say this is a client computers, this is a server. So client application, server application can connect each other by following the path. So there are many protocols used for data exchange: HTTP, FTP for FTP file transfers, which we just have seen, POP, which is used for access to emails. That's another protocol which is specifically used for emails. So the main definition of protocol is, which actually telling us that how to take place that communication. For example, how data is formatted, what is the format of the data, and also makes the rules and regulation, who speaks first, who speaks second, and then how that is moving on. So again, we have seen this thing last week as well. From where we starts, from the user program. Again, remember that these are the data packets, like protocols at every certain level they have different. So starting from on application with the HTTP, because that's how we browse on the internet. When on internet, what we do, we always open a browser, and then website usually is HTTP one, hypertext transfer protocol. Second step, on a transport layer, TCP header is added. That's header number 2, which is on the transport layer. Then on the step number 3, we have internet protocol, which is on level layer number, from the, if we say from, this is 5, 4, and 3. Okay, and then on a data link, it is Ethernet. And today, in today's lecture, we are going to cover the topic of data link layer, which is basically discussing about this header, Ethernet. We will come later on with the network and transport and physical application. We have done that. So Ethernet is the one which is on this data link layer level. Now there is a concept. Please don't ask me. Next time, come and sit. Okay. Now see this one. There is a concept known as encapsulation. Encapsulation. What is encapsulation means? Like you put all those headers together and encapsulate it, put it in one capsule type of thing. So each layer encapsulates the protocol data unit from the previous layer with a header. So for every layer, it start HTTP, it has their own capsule where they put a label on that, this is this. Then the next one, it is go inside that, and that's one of the each layer known as protocol data unit. That's important to remember. PDU. Write down this word, protocol data unit, and that is always there from every single layer, and then move toward the next one. And then header pass addressing and other information between peer layers. Peer layers mean the one which is adjacent to that. So next, this one to this one, and this one, actually everyone has the linkage with the next one, and this is how they are addressing it. Okay, that's how they are addressing the next layer, that information, that what is in the upper layer. Make sense? Okay, and then finally it is on the physical layer in a wire, where it is now transported to the next one. Please come forward, both of you. So server process occurs at the server end. The reverse process, sorry, occurs at the server end. Headers are removed, and again when it's go back, so step by step the headers are removed, and it is going till the level where then again you get the same message. This is how layer on the source device communicates with its peer layer on the destination device. So any two devices differently on different places with different relationship. Either it's a client server relationship. What are other relationships we have learned? You remember that last time? Peer to peer, yes. What else? Host based, yeah. There is one more. Yeah, cloud based, yes. So you can see that whatsoever we are learning, it is quite connected from the every week. Every week, knowledge will make sense to you when you move forward. So they are quite linked with each other. So this week we are looking toward the role of the data link. Data link is the internet model of networking. Now there are two parts of the data link. So please write down those two parts. What are those two parts? The role of the network interface card, NIC. Whenever the data link layer comes in your mind, straight away your mind tells you two things: NIC and MAC. Network interface card and identification of NIC, or which is known as a MAC address. Okay, these two things: network interface card and the identification of NIC, and we'll see how they link to each other. Then network cards are smart devices. Means they can, smart devices mean they can make a logical decision by themselves when some data comes, and based on that they can send it to the right device. Media access methods. What are the access methods? We'll see these ones in detail now after this slide. And then that's important as well: local address resolution. So for data link, if I say, most important things are the NIC and the ARP, address resolution protocol. So we'll now look to these things, how they work. So first of all, starting with the role of the data link layer. So remember that data link layer actually works in a way. It is just giving you an example. Let's say you are going to Melbourne from Sydney. First you take a bus from some suburb to your airport, and then airport you are taking it by air, you are going by aeroplane, and then in Melbourne when you reach there you may be going by train. So now you are using three different modes of transportation, isn't it? And when you ask for the agent to book my ticket, he actually organized everything for you from your home till the home in the Melbourne. So that agent is the person who is basically a protocol person for you, who is actually organizing everything for you. At the end of the day, as a passenger, your job is to reach there. So you as a passenger in this case is a data. But you know that from, let's say if you are just going from Sydney, from your house to the airport, so the linkage between from house to the airport is they only know about that. After that, they don't know what is going on. Their main job is to just take this packet from there and deliver to Sydney airport, and then it's again another person's job, because it's a totally different transportation mode. Previously it was bus, then aeroplane, then by train. So different modes, but your linkage is just to next to you, your neighbor. So in data link, it is always work with the your next one, not with the one which is apart from that. So whatsoever the next layer attached to you, it is just there. Okay. So that's important point. So it just, for example, on your own PC to the next level, their job is to take the packet to that level, and for the rest, then it's another layer level. It has their own responsibility. So another PC on your home network, a printer on your local network, the router on your local network, that's its domain. So data link layer is only working on that level. It just reaches to the next nearest machine in your network. Okay. So in your nearest network, it just go to the next stop, and that's all. Once it is reached there, that's the job of the that device to take that packet to the next level. So that's first point. So this is often described as hop to hop communication, and we have seen in the last lecture there is a hop to hop on a data link layer, if you remember that. So the question is, wide area networks involve significant distances through fiber optics or satellite connections. Would communication between two satellite interfaces be considered local networking? Yes or no? What do you think? Please read this question again. I'm giving you 30 seconds. What should be your answer? Who say no, they say, or who say yes, they raise their hand. Or if say no, then don't need to raise your hand. I need the answer from everyone. What do you think? Hmm? Okay, how many say yes? Raise your hand. Raise your hand. How many say yes? All no? Yes?
They are like same type of network.
So, okay, wait a minute. So, yeah. So, yes only is one there. So, all are no, is it? So, what is your answer? Why it's yes?
Both are satellite, so they are like same type of network.
Both are? Hmm? So, remember that answer for this one is yes. You know why? Because if some network is directly connected to somewhere else with their own network, so it is a local network for that. Still, it is on the satellite, doesn't matter. It is a possibility that one computer which is just in, let's say, when we say 10 computers in the ATMC network, they are physically located here, so they are on the same network. Similarly, if something is directly connected with satellite with 10 different computers, wherever it is in the world, they are on the same network, but we can say that's a wide area network. That's why they are considered as a, so distance doesn't matter in this case. Main thing is what is how you are going to establish a connection. So that actually tells us that that is a local networking, or either it has to pass number of IP addresses for the local one and the main server ones. It depends on that. So mainly it depends on how the networking is done. Is it clear to everyone, or still have question? Anyone? Is it clear, or any questions on that? So why? Because two interfaces are on the same network, because their interface is same, and there's nothing change in that. This applies to other wide area network, for instance, between Melbourne and Sydney as well. Let's say any specific link which you created between Melbourne and Sydney, but maybe it's on the same network. You make it a same network. Okay. Now, so what we are saying is, in the internet model, what are the things starting from application, transport? Say it with me: application, transport, internet, network interface, which is a data link layer, and then physical layer. This should be on your like a fingertips, like timetables. Like in the childhood, we remember timetables. It should be like that by next week. So that's on layer number 2, which is a data link. Okay. So data from application programs pass it down through the transport and internet layers. We haven't yet touched the transport and internet layer. So what we are looking toward is right now toward the data link, which is the data link layer is the interface between network layer, and so basically where it is located. So it's very important if I'm discussing about network layer. So this one and this one also is very important. because from there they have the relationship, and we need to see what actually this one is giving to that one and what actually this one is giving to this one. So if we know their linkage between that, then the relationship and the role and what it is doing is a very easy for us to understand. So we know that the data link layer is where we have the interface between the network and physical, and we know that physical is what? Physical is the your cable, fiber, Wi-Fi, satellite, whenever it is connected to the wire connection or a cable or a Wi-Fi connection or a satellite. These are the four different ways normally we have on a physical layer. Whenever we make a call on the make a mobile data usage on the phone, what we are doing? We are using a which one? We are actually there is one more as well, mobile network. There should be one more as well, mobile network, which is not there. But if we are at a Wi-Fi network, then at a place where Wi-Fi is there, then with the mobile phone we are using Wi-Fi. Somewhere, let's say some devices which are used for military, especially in the mountain areas or deserts where no one actually goes there, but they have those satellite phones. By them, they can also do the same networking, or the internet can work on that. Then other thing is the fiber, and then other way of communication is cable. So these are all different ways of communication. So data from the network media passes up through the network layer to the application on the receiving host. So again, on the receiving type, then it goes toward from network interface to this level and then going to the next layer. So two parts of the data link layer. What are the two parts? Logical link layer, LLC, logical link layer, and media access control, MAC. Remember the MAC, not McDonald, MAC, which is media access control, which is media access control. So these are the two important parts of at the data link layer, discussing about how they actually relate. So LLC is the interface with the upper layer, which is the upper layer on the data link. Which one? Networking. Okay. And which is the bottom one? Physical. Physical we already discussed, which is fiber, Wi-Fi, cable, satellite. Okay. So what actually it allow us to use IPv4, IPv6, IPX, and other protocols at this level. At this level, what type of bit scheme we are using? 32-bit, 64-bit, 128-bit. It depends on what type of protocol we are using. Actually, this is where it is being decided. What is the logical mean? What is logical mean? Logical. What is the definition of logical in English? Hmm?
Has a reason to justify why a certain thing is called logical.
Okay. Can we touch logic? So logic is an idea which is a non-touchable thing. Software, can we touch them? Of our whatsoever the field of internet is, it's all on a logical base where we can't actually have occupy anything. Okay, it's very much related to our human body and our soul. We can't see our soul, but it's there. The same way this is there as well. Okay, so that's the biggest proof of today's life. Like people say it's only human body, but we have a soul as well. Similarly, that's the soul is of software. If software is not there, hardware doesn't work, or maybe corrupted. So this is what we are saying is two parts of the data link layer, which is LLC and MAC. The media access control sends traffic to the network media and receives traffic from the network media. So again, media access control sends traffic to the network media and receives that information from the network media. Then the role of the network interface card. Role of the network interface card. So we know that NIC card is the main point. Please, is the connection to the network. It is totally allowed. If you want to talk, you can go outside, talk, and come back. But please don't disturb me here. So network interface card is connection to the network, which is the bottom line where it is physically connected to the wire. So notebooks and other devices often have multiple connections, Ethernet connection, Wi-Fi connection, Bluetooth connection. These are the different ways to connect them. We know that it is also on printers as well, scanners as well, routers, network devices, all have this type of, on the back end, you can see RJ45 cable is there, which is connected in the network interface card, NIC card. So remember that whenever data link layer comes, NIC cards comes in your mind. Okay? See me, talk to me. I am here as well. Okay? So NIC is the important thing, which is whenever data link comes in your mind, NIC card comes, MAC come, LLC comes in your mind, and you know that how, and you should know that, okay, this is on layer number 2 and it's connected to layer 3 and layer 1. So that in your mind, that picture should be clear. So then it makes sense to you. So routers have one NIC connected to the local network and one on the other network. We know that routers have always at least how many IP addresses? 2. So it is very obvious that whenever any NIC card is there, then it means that system has IP address. If there is a system which is without NIC, it means I can't connect it on the internet. Simple. Network cards have a unique MAC address. Again, media. So you can see that media. What is mean by media?
Media is like any sort of file.
What is media means? Medium. What is medium mean? Path. Yeah, way. So it's a path. So you can see from the meanings as well. It's giving you a path with a control on it.
Yeah.
So that's why it's a MAC. So remember from that thing, what is the media access control? It is giving you the access of that path, how that works.
Yeah.
So that's important. For NIC cards, they have a unique 48-bit MAC address. Media access control address. How many bits? 48-bit, and that's a unique for every single computer in the world. How they maintain that uniqueness? What do you think? How they maintain uniqueness of that? Do you know that? What do you think? How what would be mechanism for that to make the uniqueness of that 48-bit address of that? So basically, IEEE is the institute which basically allow or give them the licenses to different companies who made the NIC cards. What they do is 24-bit unique IP address they have allocated to the company so they know that these are reserved now. They can't give to anyone else. So IEEE is the organization who is actually maintaining the tables of every single system IP address, the MAC address. So it means that whatsoever we are using a computer or something, they know that where that computer is there. So your location can be traceable. Every single computer on the earth has that unique MAC address. 24-bit is given to the IEEE and 24-bit is given to the maker who is making it. They have their own unique numbers. Of course, then they would be always unique, because 2 power 24 is a very big number. Still in that one, millions, billions of connection are possible. Unique numbers are possible. Okay. So all data link data exchanges use the source and destination MAC address for any communication. So that's again a very important point. From this point, any person who is actually sitting on internet can be traceable, because by looking to that machine, network interface card which can't be changeable. So someone can easily see that from where that information is coming and where it is going, and those source and destinations MAC addresses are also exchanged. But nowadays, if you are using a VPN, or maybe you are using some computer which is by using TeamViewer, then it's different again, because you are not actually using that system there, you are using somewhere else, it's there, that system's computer address will go there. Yeah, traceable. So MAC has two parts which I explained. One is the organizational unique identifier.
That would be a constant one.
No, this is a first 24 bits. This is organization which is IEEE basically assigned that, and this is the unique 24 bit which is the maker, the company who made those network interface cards. So the 24 bit they fixed it from IEEE. They know that okay, this one we are giving to, let's say, Dell. This is we are giving to Lenovo. This is we are giving to, I'm not sure.
That's what I'm saying. For a particular company, there is a common number which is given by
Yes.
OUI.
Yeah.
Right?
So
And then
that's
the-
24 bit.
Yeah, and the other 24 bit would be the unique one. The
Yeah.
company is.
But those 24 are also they have the range as well. From this range they can change it.
exactly.
Yes.
That would be the range. To a
Yeah.
particular
Yes.
organization.
To a particular organization. Yeah. So hence MAC addresses are globally unique. So in that way, it's a unique one. Okay. Now coming toward the MAC addresses, how they actually look like. You can see the three different definitions: unicast, multicast, broadcast. From the word, it is clear what is unicast mean.
It is a single card.
Yeah, just one time.
Yeah.
Okay, so our frame is meant to reach only one receiving NIC. So it is only receiving to the one network interface card, and it is actually indicated by the, so they have their, you can see that they have their bit numbers from where they are allocated. So these are the unicast one only. For a multicast, a frame is meant to reach multiple but selected receiving NICs. So if you want to send only a particular network interface card, then you use those IP addresses. And if you are doing a broadcasting, then a frame is meant to reach all receiving a network interface card, then it is this one, which is using the all F, which is a broadcast message, if you want to broadcast a message over the network. So that's the main difference between unicast, multicast, and broadcast. So these are their different bytes, and the bits are using on this level. So here we can see, and also in the lab today as well, we will do a Wireshark examples, and where you can understand how actually you can see those packets, what are their bits, how they work. You will get a hands-on experience. So for example, on Windows, we used what? IP config all, which actually show us the IPv4 address, IPv6 address, and MAC address, which is also known as physical address as well. So here your physical address is there. You can see that this is how many bits? 48 bit. This is 48 bit address, 1, 2, 3, 4, 5, 6. So each having the 8 one. So then IPv4 address is here, IPv6 address is here. So these are the addresses you can see on your machine by going to the terminal and type in ipconfig/all. And similarly in Linux, we have the command ifconfig. We have seen last time as well, where you can see again, yeah, the names are a bit different. That's important. Please remember that, or maybe write down. MAC is known as HW header, whereas IP4 INET header, and then IPv6 INET header address. So that's different. Their names are different, but meanings are same. So write down those things, because sometime when you see from here, you say, okay, which is the IPv4? That is INET. This one, internet address. Internet address in the um Linux system, and IPv6 known as Internet 6 address. So coming to the next point, network cards filter traffic. What is meant by filter traffic here? Anyone? What is meant by filter traffic here? Hmm? Okay, read it this slide. Read it this slide. I will ask you what you sense from the meaning of what NIC cards are doing. What is their function?
Whatever he went to, they filter out whatever they don't want.
Yeah, when we say it's a smart devices, means they are intelligent enough to see which data they need and which they don't. This is mean by filtration process, like filter it what they need, and don't then take it which they don't need it, or which is not for them. So every packet is coming on the network only passes that one which is for that computer. Packets that are for other machines are discarded. Packets for the host device are delivered to the host device. To do this, NIC interrupts the host and passes the network packet to it. So if something is for the host or for the routers, so it is delivered to the host devices accordingly. And that's the job of the NIC card. The host machine only deals with important network traffic, not packets that other devices must process. Hence, the filtering of traffic by the NIC reduces processing by the host machine, and hence does not impede host performance. So what they are saying is, usually with a normal computer, that's different type of filtering of that packets. But when it's going toward the host one, then the process is different for the host machine. So try to reduce the, so they know that okay, this is for host. So without filtering, you can simply reducing the activity over the network. You can send to the host, and it takes less number of turns to reach at the host. Okay, next important thing. How NIC check for errors? Of course, whatsoever is going on the internet, the data is transmitted. We know that they are in the format, they have the data in that, and we do the encapsulation process on each system level. With so many things, there is a very high possibility that when it receive at the receiving end, the data is not what we have sent. How we can know that the person who is sending the data and person who is receiving the data are same? Okay, so what we need to do for that? What we need for that? That's basically, there is a concept known as cyclic redundancy check, CRC, cyclic redundancy check. Again, further going into detail, see the meaning of that three word meanings. Cyclic,
Means cycle.
in the circular, it's a keep ongoing process forever. What is redundancy means? Hmm? Data replication means whenever data is going over the internet, there is a duplicate packets are always there to help that packet if something is missing. Check mean check. So of course that will check always, like we have a redundant packets available. From there, what we need to do now, prior to sending a packet on by a NEC, perform a 32-bit CRC calculation that characterizes the content of the network packet. What the 32-bit CRC is appended to the end of the packet, then sent to the destination. So it means that whatsoever your packet size is, it always has a 32-bit CRC attached to the packet. Okay. When the packet arrives at the destination, its NIC does the same CRC calculation on the received data. So one calculation of CRC is done on the transmitting end, one is done on the receiving end. So both end when do those things and they match it, if they are same, they say okay, that means like message is 100% correct and it is properly sent to that destination person. This is the same way like when in the intelligence companies or military agencies, people work in as a spy. When they go somewhere, they share the codes first. When they share the code, if that code is correct from the other person, then they speak to next to, okay, this is the right person. So similarly, this is a kind of check which is there in the computers as well. So yeah, so if the two CRC are different, it will just corrupt the data. It means that it is not for that particular computer or for that device, because it is not making the same answer for that. And this is type of error checking is common in networking. We will see some maybe more in detail about CRC, how that calculation works. These are the bit numbers, we add them together in the lab today, or we'll see if we have more time. I will give you a more understanding of that thing, how that actually works. Then we are coming toward the Ethernet frame format. Ethernet frame format. So again, remember that we are on which layer we are talking today? Data link layer. What is the top of the data link layer? On top of it? Network. And bottom one? Physical. What are the main two importance of data link layer? LLC and MAC. And MAC address. And MAC address means what? Network interface card. Okay, NIC card. And NIC card has how many bits? 48. Out of 48, 24 for what? For organization, and 28 for the maker. 24 for who make the device, and 24 for the organization IEEE assigned to them. So they can ensure that it is properly having a unique ID numbers. So coming to the point now. Ethernet frame contains the payload from all upper layers, which consist of header and the upper layer protocol data. So you remember that from the application layer when it starts, HTTP, then on transport, TCP, and then internet, and then IP is added. So every single header is added with the encapsulation process. And yeah, so remember that what we from the onward we call them this is as a data itself. This is as a data. For example, when we call now a 32-bit frame check sequence is attached to the end of the frame, the destination and source MAC addresses are also required to specify where the packet came from and its destination. So always with your packet, it's sent where it is going, that address is attached as well. From where it's coming from, that address is attached as well. So this is actually known as a refer as a data, like IP, TCP, HTTP as a one thing. We call them right now because what we are learning, data link layer. So for rest of the things, we will take as a data, which is not as the headers. We say HTTP, TCP, IP is a complete capsule which is given to data link layer as a data. So that's why to make it more simpler, because we are focusing on data link layer. So data link layer receives the data, and then with that data, what it adds? Source address and the destination address, both addresses, source and destination. So this is how the format of Ethernet frame look like. So what is the data in that? In this one is HTTP, TCP and IP. So this is already embedded in that. CRC, cycle redundancy check is added. Source MAC. What is a MAC? MAC means media access control. So that one is source, and for the destination MAC, both are there. Okay.
And the flight one, what?
We will come. Hold on. Yeah. So this is the direction of travel.
Okay. First it checks.
First it has a circular density check. It has a data, some type. What's the type of that? We'll see. MAC, source MAC address, and source destination address. And those addresses are what? These are the unique. Is it a permanent address or a temporary one? Permanent one. Your IP address can change, but that can't be changed. So the data field is often the largest part of the frame. It contains, we know that HTTP, or if it's FTP, whatsoever it is, plus any header from upper layer protocols. So now we can see that in a Wireshark tool that is used to check the network traffic, how it is going on. So you ping a packet. So this is an Ethernet frame. Okay, so you can see that on the Ethernet frame, it has a source, but of course here it is not showing properly. But and when you click it there, just want to show you here, everyone, please have a look. I'm not going to explain too many times in the lab. See it here, yeah. When you're doing that step, having some issues or struggling, then it's a different thing. But when you're looking to ping the packet in the lab, remember that when you click it on Ethernet, this one, because remember the Ethernet frame, how it looks like. When you click it, it always show in the form of, this is the equivalent of this one, because this is in the form of a bits. Okay, so we'll see this one more in detail in the lab as well. So it's a 74 bytes in length. The length of this header is, Ethernet header is 74 bytes in length. The first 14 are the Ethernet frame. Okay, and from out of that 6 bytes are Ethernet destination one. So it means that from here you know that what is the destination of the Ethernet address, where it is going. Okay, and then looking toward the next one, which is the 6 bytes are for the source MAC address. And for the type you are saying that it is IPv4, IPv6. That was the type. Again, remember that how to read it. You can see 74 bytes. Click it on Ethernet frame. It will automatically show you the form in the form of a bytes or bytes in that. And first, this one, 6 are the destination, where it is going, then source, and then what type of that Ethernet is. That's IPv4 we are using. Now coming toward the broadcasting address. Broadcasting means like as I mentioned last time, what is the broadcasting?
One source and destination. One-way communication.
One-way communication, which is like radio stations, they broadcast only. The listeners can listen only, they can't give them the answer back on the network. So if the destination MAC address is an Ethernet frame is all binary ones, it means that the frame must be processed by all machines on the local network. So if there is a host machine, maybe they are broadcasting something. So if there is something like that, which is having the same all binary ones, like FFFF, it means it is broadcasting to the whole network. Let's say in one network there are 50 computers and you want to broadcast something, maybe with this packet information it goes, it means that now it is in the broadcasting mode. So such broadcast packets are a requirement of many network protocols. And we'll see ARP and we'll discuss later on. So when expressed in hexadecimal, a broadcast address is 48 bits with all, why F mean? F is equal to, what is the F stands for? Let's see, who can answer? Hexadecimal, yes. So it's a hexadecimal equivalent. If we convert it into binary, from hexadecimal to binary, F equal to 4 ones, because 15 is in decimal. Binary 15 is how much? 4 ones. 1 1 1 1. That's why all are 1 and it's become 48 bits. Is it clear? Okay, here just we take a 2 minutes break and then start. Okay.